Hello data managers, this is Mr. Dunbar and activity 1 for unit 6. We are looking at probability and the probability terms in this video. Now here we have a nice picture of a shamrock, that is an oxalis plant, and a nice green hat to represent the luck of the Irish. Now, first of all, what exactly is probability? Well, it's the branch of math that attempts to predict answers, and what it does is deal with chance, with random variables, and the likelihood of outcomes. So to do probability, we need to do probability experiments. So probability experiments is one where we do a number of trials where we observe the outcomes, and ideally those outcomes would be clearly distinguishable from each other. So in the example that we already looked at, in Chad's probability experiment for getting out of jail, what he did was observe the ways that he was able to get out of jail, and he did it systematically, and he did it 200 times, if you'll remember. So we also have outcomes. Outcomes are the results of probability experiments. In Chad's case, he has 3 possible outcomes for each particular round in his probability experiment. So he could get out of jail free card, he could roll doubles, or he could pay $50. So that was an outcome for his probability experiment. And this is a snapshot of the content. And what he would do is he'd run a trial. And a trial is a single step in a probability experiment, and what it does is it produces an outcome, and that outcome is then tallied, it's recorded. So here we've got a tally sheet that Chad likely created. So he likely created this summary table, and what he would do is mark a tick next to each appropriate outcome whenever it occurred. So whenever he landed in jail, he would mark a tick. Whenever he rolled doubles and got out, he would mark a tick. Whenever he drew a get out of jail free card, he'd mark a tick. And finally, whenever he paid $50, he would mark a tick. This is obviously not the full 200 events. This is 10 events. And in case you're not familiar with this way of recording, what you do is you mark 4 vertical lines, 1, 2, 3, 4, and then you draw a slash through those 4 lines to mark a 5th. And that way you've got a grouping of 5. I imagine most of you have seen that method of recording. Now, there's also this concept of the sample space. So that is all the outcomes from a probability experiment, and it is considered a set. It's a mathematical set. So in the case of Chad's example, that sample space is 200 because he landed in jail 200 times and tracked how he got out 200 times. Here we've got a nice snapshot of the next bit of the course content. Then we have the idea of the event. So the event is the collection of outcomes that satisfy one condition. So you take one particular outcome and you count up how many times that particular outcome occurred. And the probability of an event, of an outcome, it ranges by definition from 0 all the way up to 1. If it's 0, it does not happen. It's impossible. If it is 1, it is a certainty. So in the case of Chad and his get out of jail free with a card event, in that case, that happened only 4% of the time. So let's take a look at how we determine the probability of an event. Well, we're going to define the variable A as the event. So it could be getting out of jail with a card. That's going to be variable A. Then the probability of A is going to equal the number of times the event occurs, N of A, divided by the number of total events in the sample space, N of S. So in Chad's case, we're going to say B is the event, and that event is going to be get out of jail with a card. And then the probability of event B is happening is going to equal the number of times that occurred, so it occurred 8 times, and the total number of events in the sample space was 200, so the probability of getting out of jail free with a get out of jail free card is 8 in 200, or 4 in 100, or 4%. So that is the probability of an event. Now, to finish off, we have this concept of the complement. So that's the chance that an event does not occur. And that means the set of outcomes that does not include that particular event. So going back to Chad, what is the complement of getting out of jail by rolling doubles? That is when you get out of jail by drawing a card or by paying $50. Okay, so the complement of getting out of jail by rolling doubles is when you draw a card or when you pay $50. So let's take a look at the math that goes into that. So here we've got it broken down. The probability of not rolling doubles is equal to the probability of getting out of jail free with a card or the probability of paying $50, which is going to equal the probability of drawing that card plus the probability of paying $50. So in this case, because the events are mutually exclusive, you add things together. So it's an OR situation. Now let's ask the question, what is the sum of the probabilities of all the events? So that's the total sample space. So the probabilities of all events in a probability experiment do add to 1. If they don't add to 1, it means that you're missing an event or you've got rounding errors. So the probability that you roll doubles plus the probability that you draw a card plus the probability that you pay $50 is going to equal 0.325 plus 0.040 plus 0.635 equals 1. So how do we calculate the complement? Well, we subtract the probability of the other events from 1 to give us the probability of the event we're interested in. So we're interested in the probability of getting out of jail without rolling doubles. It equals 1 minus the probability of rolling doubles, which equals 1 minus 0.325, which in the end equals 0.675 or 67.5%. Now, I want you to pause the video here and reread this slide. And then pause it again and reread it and reread it. And the reason for me wanting you to reread it is that this concept crops up in so many different facets of your life. This idea of complement. Being able to figure out the probability of something happening based off of the probability of something else not happening. You see that everywhere, and if you are able to recognize the complement of an event, it will allow you to be much more effective in figuring out things and understanding statistics. So I strongly recommend that you spend the time to understand this concept of the complement. Now, that's the end of this section. If anybody knows this reference, go enjoy a good book. Anyway, continue on with your work and do make sure that you are learning as much as you can.